Hey Chem students, this tutorial is going to focus on mass to volume stoichiometry. We're going to work through one example together and we're going to follow the following steps. Now these 4 steps may be used for mass to volume stoichiometry as well as mass to mass. So first and foremost, we're going to check that our equation is balanced. Whatever we are given in the beginning, so whether that's mass or volume, we're going to convert to mole. And we'll use our mole ratio to go from mole of our first substance to mole of the second. And then we'll follow the last step, converting our mole to either grams or liters based on what we were asked to find. So our question is, how many grams of pentane, here's its formula represented C5H12, are necessary to produce 5 liters of carbon dioxide in the following equation? So our equation is already balanced, so we're going to move on to step 2. We were given that we had 5 liters of carbon dioxide produced. And we are asked how many grams of pentane are necessary for this reaction to take place. So I'm going to put question mark, grams, C5H12, and 5 liters of carbon dioxide. So we're going to start by writing what we are given. So we have 5 liters of CO2. Our first step after we've balanced is to convert that to mole. So you may remember that 1 mole of a gas at standard temperature and pressure will occupy 22.4 liters of a volume. So my liters will cancel. I'm going to multiply across the top, divide by what's on the bottom. So 5 divided by 22.4 is 0.22 mole of CO2. Alright, so now we're going to use our second step, or number 3 on this list. We're going to use our mole ratio. So we're going to go from mole of carbon dioxide to mole of pentane, C5H12. I'll leave a little extra space. Alright, so now I'm going to use that mole ratio. So that means I'm going to look at my coefficients. I know that for every 1 pentane, 5 carbon dioxides will be produced. So it's a 1 to 5 relationship. So to cancel out my CO2, I'm going to put 5 mole of CO2 for every 1 pentane. So that's going to go on top. Mole of pentane, so C5H12. So my mole of carbon dioxide will cancel out. I'm going to multiply everything across the top, so 0.22 times 1 divided by 5, and I have 0.044 mole of pentane. So I'm not quite done yet. Now that I have my mole of pentane, I'm going to convert that to grams of pentane. So I'm going to move down here. So 0.044 mole of pentane. And I'm going to convert this to grams of pentane. Alright, so I need the molar mass of pentane. So to be able to go from mole to mass, I'm going to need molar mass. And I know that in 1 mole of pentane, I will need 72.151 grams. So there's 72.151 grams per 1 mole of pentane. So this is the molar mass of 5 carbons, 12 hydrogens. So my mole cancels, and now I'm just going to simply multiply across the top. So I'm going to multiply 0.044 by 72.151, and my answer is 3.175 grams of pentane. Alright, so practice some more of these on your own. Keep to just a simplified version of the steps. So balancing, converting what you're starting with to mole, using a mole ratio, so a mole to mole, and then your last step would be just converting to what it is that you were asked for. So remember those conversion factors that we learned in the mole unit. As always, ask me questions.